Right, I just want to address something, and it's some confusion about, let's say I give you something like this. Okay, so we've got two very different things. One of these things is linear. The other thing is would expand out. It's a quadratic, right? It's a linear getting squared makes a quadratic. Now, let's be clear. We can expand this out. We can expand the brackets, and we can say that this is 2x plus 2, right? No problem. Okay, no problem. That's supposed to be a smiley face. Let me do it again. No problem. There we go. Now with the one on the right, we can expand this out as well. Let's see what this actually is if we expand it out. Well, first of all, I'm going to write the x plus 1 all squared as an x plus 1 times an x plus 1. And then what I would ask you to remember is if it was something much simpler. Say, for example, and I'll come back to this this screen in a second. I'm going to go to a blank screen. I'm going to do something simpler. Okay, I'm going to do 2 lots of 3 squared. So, because of bid mass, so there's lots of different ways we can look at this, and I'm actually going to show you a few different ways. The first one is because of bid mass, we do the indices before we do the multiplication. So this is 2 times, and I'll do 3 squared, which is 9, and then that's 18. Right, that's the correct answer. I can also actually write this out. This is 2 times 3 squared, but 3 squared is 2 times 3 times 3. And this is where I think some people are getting a bit confused when it applies in this more tricky situation. Because I'm not doubling both 3's. I'm not doubling them both. This is not 6 times 6. It's not 36. It's 2 times 3, which is 6, times 3, which is 18. So you can do this 2 times 3 first. You can do this first. You can do 6. And then still times 3. And that gives you the same answer, 18. Or I've got 2 times 3 times 3. And I could do this 2 times this 3 first. That's 2 times 3, which is 6, times the remaining 3, which is 18. And I've also got the order which is similar to this. I could also do 2 times and do 3 times 3 first, which is 2 times 9, which is 18. Any way you look at it, you get 18, right? You get 18. And the point I want to make is that the 2 is really only there once. Okay, it doesn't times this 3 and then also times this 3 to create 6 times 6. That's not what's happening. So if we look at the more complicated situation, which is like this. Remember what we did? We could do 2 times 3 and then times the last 3. Or we could do 2 times the last 3 and then times that 3 in the middle. Or we could do the 3 times 3 and then times by 2, right? We only get to use one of these things once, and then it's been used up, and then I get my final answer after I've done everything. So in a similar situation, I could do, if this was the 2 times 3 times 3 situation, imagine I wanted to do the 3 times 3 first. That would be a 9, and that would be 2 times 9, which is 18. It would be like saying I'm doing this double bracket first. So I can do that double bracket first. So this is 2 lots of, because remember, you're going to get an answer, and then you're going to double your answer. You're going to times your answer by 2. So if you use a grid method, you'll see that the answer is x squared plus 2x plus 1, and then I'll times that answer by 2 to get 2x squared 4x plus 2. So one possible way of getting the answer for this being expanded is 2x squared plus 4x plus 2, and I do the double bracket first, right? I can do the double bracket first. So let me just write the answer up here, and then I can get rid of the working and do it in a different way. So this is the answer that we expect to get. and we can do it in a different order. This time I'm going to do it 2 times, basically like doing the 2 times 3, which is 6, and then multiplying that answer to get 18, times it by 3, the last 3 to get 18. So here I'm going to do this one first, get an answer, and then times that answer by x plus 1. So we've just seen what 2 lots of x plus 1 is. It's this, right? We actually just did it. So this is 2 lots of x plus 1, which is 2x plus 2. And then that's the answer to this part. And then I've got to times that entire thing by x plus 1. And then, okay, I've got a grid method to do. So let's see what we get if I do the grid method. So 2x and 2, x and 1. So I get 2x squared, 2x, 2x, and 2. And I get the same answer as I got before, because it, as you should know, it doesn't matter what order you times things in. Right? It's like it's the same answer. Okay? The same answer. And this is where some people are making a mistake when they are doing their completing the square. Let me just get rid of this. Because instead of just, because when you complete the square, you'll often end up with something that looks like this, and then maybe plus a number, right? So plus, I don't know, a number. Like, you know, when you complete the square, it usually ends up looking like this. A lot of the time there's not a number there, but the trickier examples do have that. And what some people have been doing is they've been bringing the 2 into the bracket, and they've been writing, and I'll put a big question mark because it's going to turn out that this is actually wrong. They've been writing this. They've thought, okay, I can bring the 2 inside this bracket. But you can't do this. This is wrong. Let me show you 2 reasons why it's wrong. Firstly, I'm just going to expand this and show you that we get something different. And then I'll explain why we are getting something different. So this would be 2x plus 2 times another 2x plus 2. And those of you who were really concentrating might spot why this is already wrong. Because if you compare it with what we wrote before, it's not the same thing. 2 has, as if by magic, because it's, you know, and it's wrong, it's times both of the brackets. It's like we've done 2 times 3 and then another 2 times 3 and we're doing 6 times 6. That's wrong. 2 is allowed to come into, say, the first bracket, but then you can't bring it into the second bracket because it's already been brought into the first bracket. So if I actually expand this out, I get 4x squared plus 8x plus 4, right? And it's just not correct. It's not the same as the right answer. Okay? And the reason is basically for the reason I was just saying, that the 2, I mean, if I write it out without the square, 2 lots of x plus 1 lots of x plus 1. Okay, you can times by the 2 in this bracket, so this would be 2x plus 2, but it doesn't also get to times this bracket because you've already used it up when you've times this bracket. That's now correct. Okay, it's very similar to the idea of doing 2 times 3 times 3. You can do 2 times this 3, that's fine, that's 6. But now you've got an answer, okay? You've got 6. The 2's gone, basically. Well, it's been incorporated into the 6 by doing 2 times 3. But it's not still there. It's not now timesing the other 3. It's 6 times 3 now, which is 18. And in this more complicated situation, it's 2x plus 2 now times x plus 1. So, okay, you can say it's this if you want, but that's actually not the way we write a completed the square answer. We want it to be left like this. And this goes for anything like that, by the way. If it was a 3 on the outside, 5 on the outside, you don't want to bring that 3 or that 5 in, Because if you do, then you're actually, what are you doing when you bring the number in? You're squaring the number, but you shouldn't be. This number out on the front isn't being squared. And that's why you should not bring it into the bracket, because the bracket is being squared. Over here, it's okay, because the bracket is not being squared. Okay, the bracket has, this is a 2 to the power of 1. This is also a bracket to the power of 1. It means you can multiply into the bracket. It's fine. Okay. Over here, though, the 2 cannot just freely come into this bracket and that be it, because that bracket is actually being squared. So you want to leave it like this. Okay. So in a more, in a more complicated situation, I just make up some question: 3x squared plus 5x minus 6. Let's do that. So I'm going to complete the square. So I need to bring a 3 out the front and write x squared plus 5/3 x minus 2 equals 3, and then I complete the square on the inside. So this is x plus 5/6 all squared, still minus 2, but now minus 25 over 36, which is 3 lots of this big bracket, x plus 5 over 6 all squared, minus, I guess this is 72 over 36, because 72 divided by 36 is 2, minus 25 over 36, so that's still there. Continue up here. This is 3 big brackets, x plus 5 over 6 all squared, minus 97. 72 take away 25 is 97. So minus 72 take away 25 is minus 97 over 36. And now I can times back out by the 3. When the 3 times is this thing, you get 3 lots of that thing. Right? And you leave it like that. You leave it like that. The reason you leave it like this is you cannot now bring the 3 into this bracket, because then what you've really got is 9, not 3, because you'd be squaring that 3, but you shouldn't. The 3 is not being squared. So you just leave it like this. That's it. That's fine. Of course, you must also do 3 times this, which will be 97 over 12. And it's a takeaway, isn't it? And then that's your final answer. So there were a few of you who in a question like this were bringing the 3 in and writing 3x plus 5 on 2. And then maybe even going a step further and using that as a number there to then help work out this number. So it was like a double whammy. You got that first bit wrong and then you got the second bit wrong as well. I just want to try to make it as clear as I possibly can, guys. Even if you don't fully understand the whole, the 3's not being squared, but this bracket is, so don't bring the 3 in. Even if you don't get that, just do what I'm telling you to do. Leave that number on the outside of this bracket being squared, okay? The bracket's being squared. The 3 can't just come in. If there wasn't a squared there, you could do 3x plus 5 over 2. It'd be fine. But since there's a squared there, the 3 can't come in. It can't. Because then you'd be squaring it and it's wrong. Right, hopefully this has clarified things. Maybe it's something I'm going to have to talk about more in class. If so, that's fine. Just enough people were making this sort of mistake that I wanted to make this video. Okay, thanks. Bye.